Hi everyone, hi, how are you? Welcome to another video. So in this video, teacher's going to do part 2 for probability distribution. Okay, part 2 will be about binomial. Now, before teacher start, okay, I want you guys to let me know who is the mathematician or how this binomial actually started, how this calculation. Now, this is just a very rough picture of who the person might be. You can read it through your textbook, you can Google him up. Okay, what teacher want you guys to do is, okay, write down in the comment section below who is the mathematician that actually did this binomial distribution calculation, the one who actually started off. And also, okay, what teacher want you all to do is, once you write that in the comment section below, okay, don't forget to subscribe, don't forget to share this with a friend who you think they will benefit from. Okay, so let's get started. So today we're going to look at binomial distribution and how, okay, you can do calculations for any events that happen. Okay, usually binomial distribution, okay, you will have outcomes. All right, for example, okay, you already learned what are outcomes, right? Okay, when you do an experiment or when you play a game or when you throw a dice, okay, all these you have outcomes. Okay, what are the outcomes? But here now, okay, this binomial distribution, the outcomes will you will have probability for success P. Okay, you will have success. What is the success probability? And the Q will be the failure. What is the failure for the experiment, for example? So usually you will have two outcomes. So success, failure. Okay, so binomial you have two outcomes, and to find the failure, okay, actually you just take 1 minus P only. Okay, remember in the beginning of this chapter, our teacher got explained that binomial always, probability distribution always the entire calculation is 1. Okay, the whole thing should be 1. All right, now let's look at how to apply the formula for binomial distribution calculation. Okay, because for this part you have formula to use. Okay, and you can also check in your SPM formula paper. Okay, you usually have the formula given. Okay, so not to worry actually, but as always, it's good to memorize. Okay, memorize your formula, know what it stands for, so that you don't like no like kelang kabut or you don't like panic during the exam. Okay, now let's look at the formula. Formula is quite easy to memorize. Can use a bigger one. All right, this is the formula. Okay, look at the formula carefully. If you see the formula, there is different letters, right? Okay, you have N, C, R. Okay, let me explain first one by one why we are using this formula. Okay, because number one, binomial distribution is used for a very large population size. Okay, what does it mean by large population size? Okay, it means that, for example, if I'm going to do an experiment, I'm no longer just going to do experiment for 3 times I throw the dice, okay? Or maybe like, okay, maybe it's 3 times, or maybe like 2 times I throw the dice. So before this, if you still can remember, whenever you do experiment, you use tree diagram, isn't it? You use tree diagram. Okay, now if you realize, okay, in this part onwards, you would not be able to do tree diagram anymore because the calculations all have larger size already. Okay, large size. Okay, the size is the one. Okay, large size is the one, is going to be your n. Okay, n is going to be the size. Okay, now let's look up. Okay, so here teacher write for you. So n, okay, n is going to be the over here. Okay, for you to know like the entire total, what is the total number of experiment you are doing. That is the size lah. Okay, that is the size. So number of trials. So if like you're writing these together with teacher will be good because like you can like memorize it even faster. So N number of trials. Okay, what is C? Okay, you all already know C is combination. C is combination and P is permutation. Okay, this one combination, permutation. Okay, probability of permutation, combination. This one all we already learned in chapter 4, the C and P. Okay, that one I'm not going to write down. Next, let's look at R. Okay, what is R? R is the number of success. Okay, for example, uh, let's say, okay, we'll look at examples of this. Okay, let's say you throw the dice 4 times, okay, and what is the probability of getting a number less than 5? So that means your let's say 3 times you get, so 3 is your number of success. Okay, now if teacher explain like this, might be a little bit confusing, but let's look at example later. Okay, so R for now you have to know is number of success. Okay, R done, N done. Okay, Q already you all know. So P, make sure you know P is the probability of success. This probability, okay, probability of success, and Q is probability of failure. Okay, probability of failure, and also make sure you know what is your X. Okay, X is the discrete random variable. So R already got. Okay, P you know. Okay, all of you should know P is probability. All right. Okay, so I think that's all. I already covered the formula. Formula is very easy. Okay, and another thing. Okay, you should also know the way. Okay, how to write binomial distribution. Okay, binomial distribution, should know the way to write it in terms of parameters. Okay, binomial distribution you usually write like this. Okay, the sum of the experiment from first number of success to all the way n. Okay, x r equals to binomial n and p. Okay, n is the you already know number of trials. Okay, p is the number of success. Sorry, probability of success. So when you write, sometimes in exam they will give you in this format. So you must know how to take the information from here and apply it. Okay. So far so good. Okay, now teacher is going to go into question how to apply. Okay, let's look at this question. Okay, a dice is tossed 4 times. Okay, 4 times, so they throw the dice 4 times. If X, okay, this is very important for us. You must know what's your X. If X is the number of times, okay, getting a number less than 5, find the probability that exactly 3 times the number less than 5 happens. Okay, first, okay, we're going to now apply all this. Okay, we're going to apply our formula here. Now, before we apply, we must know what is our X first. Let's list down our X. Okay, number of times getting number less than 5. So, okay, look carefully. How many times we toss the dice? We tossed 4 times. Okay, so out of the 4 times, okay, maybe 4 times also the number less than 5 did not happen. Okay, did not happen. You didn't get number less than 5. So 0. You didn't get. Okay, you throw your dice, isn't it? You throw your dice. Okay, this is your dice. You throw the first time, you get number 6. You throw the second time, you get number 6. You throw the third time, number 6, and you throw the fourth time also, number 6. So 4 times you throw also you get number 6. Okay, number 6 or number 5 between this. Okay, so 0 times. Okay, number of times getting number less than 5 is 0 times. So maybe 0 times. Okay, maybe first time No, didn't get less than 6. Second time didn't get. Third time didn't get. Fourth time maybe we got number 2. Okay, we get 2. So maybe one time the thing happened. Okay, or maybe we throw the dice. Okay, first time didn't happen, second time didn't happen, third time, yes, third time you get maybe number 3. Okay, you get number 3. So yes, here 2 times. So you get 2 times. Or maybe first time didn't happen. Second time you got number 1 from the dice. Number 1. Second time number 1, and then third time you get number 3. Fourth time you get. So I'm following this order. Okay, so hope you guys follow it. Okay. Or okay, so this is 3 times. Or what is the last option? First time itself you get a number less than 5 already. So maybe you get number 4 here, first time. So first time also get, second time also you get number less than 5. Third time also we get number less than 5. Fourth time also we get number less than. So all the 4 times when you throw also, you get the number less than 5. So this is our x. So remember, you must always know your x first. That means you must count first how many times the thing could have happened. Now you can, alright, now you can find the probability. Okay. So remember, this one, our probability is what? For this probability, we get a number. Okay, we are getting a number less than 5. So what is the probability of getting a number less than 5? Total, we got 6 numbers, isn't it? Total, we have 6 numbers. So if I get less than 5 means, that means number 1, number 2, or number 3, or number 4. So total, I got 4 possibilities only. 4/6. This is my probability. Probability of getting a number less than 5. So remember, you can simplify this, becomes 3/2. So this is your P. So you already found your small p, this one. Small p found. Okay, now that we already found our small p, it will be easy for us to find the q also. Q, just take 1 minus 2/3. That means we will get 1/3. So P done, Q done. Now let's look at question A. So usually you can find all this information before you even start the question. Okay, question A, find the probability exactly 3 times. Betul-betul tepat-tepat 3 times it happened. So first step, right, probability x equals to 3 because it happens exactly for 3 times when you throw the dice. So now this is your, what is the 3? 3 is what here? If you look at your formula, 3 is your R. So R is what? Number of success. So that means 3 times it successfully came out less than 5 lah. Okay. So how do we write? Start with n. What is n here? What is our n? N is very obvious already. This part. 4 times, isn't it? So this n is 4. Okay, remember n is 4 because 4 times we tossed. Okay, so n is 4. C, okay, 3. Just follow the formula, okay. Is NCR PR QN minus R. Okay, this is the formula. So just write here back again. Or if you have your textbook with you, refer your textbook and do together. So what is our P? P is 2/3. What is the R? R is 3. What is the Q? 1/3. What is the N minus R? N minus R is take the 4 minus the 3. So 4 minus 3 is 1. Okay, so let's key in the calculator. Okay, key in one shot. See, 3, 2/3, power of 3. Okay. Make sure get the same answer as teacher because most students sometimes they get it wrong. Okay. Alright, so teacher get 32/81. Okay, or you can write it in decimal also. It's going to be 0.32. 3951. So, okay, the moment you already analyze your information, you can just straight away plug into the formula. Okay, now let's look at B. A number less than 5. A number less than 5 does not occur at all. This is your keyword. Does not occur at all. Doesn't happen at all. So if doesn't happen at all means what is my probability? That means probability x equals to 0, because when I throw the dice, it didn't get at all less than 5. That's what it means. So we already know x here 0, so that means substitute in the formula. Okay, and all we know already. So 4C0, P is 2 over 3, 0. Q is 1 over 3, 4 minus 0 is 4. So we key into the calculator. 4C0, and then we have 2 over 3 power 0, you will get 1, okay, times 1 over 3. Okay, I get 1 over 81. Okay, hope you all also get the same. Okay, and you can also write in decimal. So we are done with this is kind of question. So this kind of question is easy. Okay, all you need to know is find the information correctly. Okay, find the information correctly. All right, let's try another question. Okay, this question, let's try it with drawing a graph. Okay, let's try by drawing the graph that we already learned in previous video. And by the way, the previous video teacher got do the correction in the comment. Please take note, I just actually switched the place of drawing the probability graph. Okay, other than that, the method all is correct, just the final part I switched. Okay, I accidentally switched. All right, thank you so much. I know some of you students who are watching, you notified teacher. Thank you very much. Okay, so this is the question that we are going to look at. The type of question that your mid-year exam might come out, okay, because it's like you have up to 7 marks for this question. So let's look at the question, how to answer one by one. Because the most important thing is you understand the information. Okay, the moment you understand information, any type of question you can answer. Okay, Malik fires 3 shots at a target. Okay, 3 shots. The probability that he that means this is he strikes the target is 0.8. So what comes to your mind when you see the word strikes? That means is something successful or a failure? So obviously this is a success. So I'm just going to write here first. Okay. The random variable x represents the number of times Malik strikes. See, this confirms, okay? Malik strikes the target. So this is our success, okay? The x. They want us to they want us to use the x for number of times strikes the target. A. List the possible elements of x. Okay, this question is always 1 mark only. Now, how are you going to list? Very easy. Okay, first, how many, so x you already know, x is what? Number of times. Okay, I'm just going to write first. Number of times Malik strikes. Okay, strikes means he hits the target. Okay, number of times Malik strikes the target. Now, total how many times he shot? Total he shot 3 times, right? So that means, okay, if he shot 3 times, maybe for all the 3 times he shot, okay, 3 times, 1, 2, 3. Let's say he's supposed to shoot in the middle here. First time, second time, third time. Okay, these are the shots. Okay, let's say the first attempt here, this is the second attempt, this is the third attempt. Okay, I'm going to erase this first. Okay, first time he's doing. First shot didn't get. Second shot didn't strike. Third shot didn't strike. So that means all didn't strike. So what does that mean for the X? So the x is 0. Okay, now let's say first shot didn't strike. Second shot didn't strike. Third shot he struck. So maybe he only one time only he strike the target. Can also happen, right? Or first time didn't strike. Second time strike. Oh, very good. Third time also strike. So maybe two times Malik strike the target. Or it could have also been first time itself he strike the target. Second time also he strike. Third time also he strike. So it's hat-trick. No lah. Okay. So 3 times strike. Okay. So these are the possible, okay, elements, possible outcomes. So this is how you list. Usually you use the set notation, okay, or you can also use x equals to 0, 1, 2, 3 also can, okay, but it's very common to use with set notation. This is only 1 mark. Done. Next, go to B. Okay, calculate the probability for the occurrence of each element of x. What is our x? X is all this, isn't it? 0, 1, 2, 3. So they want us to calculate the probability. Okay, if 0 times means, okay, let's say 0, he didn't strike at all. What is the probability? Oh, he strike 1 time only. What is the probability? Oh, he strike 3 times also. What is the probability? Yeah, that's what it means here. Okay, the question. So what you have to do is, okay, now find the information first, because now what we're going to do is we're going to put into the formula, isn't it? N C R P R Q N minus R. So we need the information. Okay, let's do the information first. We should know what is our N. Okay, what is our N here? How many shots? 3. So total N is 3. Yeah. Okay, N is 3. What is our R? R will be, okay, R will follow this, okay, R will follow this 0, 1, 2 and 3. Okay, R will follow all that 0, 1. So we have to calculate one by one. P, what is the probability for success? Is it given? Usually it's given in the information. You just have to read properly. So you see here, probability of success is 0.8. So I'm going to write probability of success 0.8. So automatically I can already find my Q. So 1 minus 0.8 is 0.2. So don't ask teacher why 1 minus, I already explained. Okay, the entire thing usually is 1 calculation. Okay, so we already have all the information. Now let's substitute in. Okay, so usually this one you can also write in binomial form like this. Okay, so n is 3, 0.8. Okay, this is the information. Okay, now let's find starting from probability x 0. That means he didn't strike at all. No strike happened. So 3C0, 0.8, power of 0, 0.2, power of 3. Okay, let's see, calculate carefully. Key in your calculator. 3C0 times 0.8 power of 0 times, so usually that one is 1 lah, 0.2 power of 3. I get 1 over 125. Or usually you can write in terms of decimal 0.008. Okay, you can write in decimal. Next, let's calculate probability when he strike 1 time. Satu kali. So 3C1, 0.81, 0.22. Okay, you know where teacher's getting this? I take 3 minus 1. That's why I get 2. Okay, so key in your calculator. 3C1, 0.8 power of 1. Key together so that we can see whether your calculator skill is there or not. 0.096. Next, probability x equals to 2. That means he strike 2 times. 3C2, 0.82, 0.21. So here you get 2, then 1 0.384, and the last one we are calculating when he strike all the three times or so that he shot. 3C3 0.83 0.20, because 3 minus 3 is 0, right? Okay, so here we get 0.512. So we have calculated for each occurrence. That means for each possibility lah, okay, maybe 0 times means 0.08. Okay, one thing teacher want you guys to try now. Okay, now since we already calculated all these, right? Okay, take your calculator, uh, plus all these numbers. Teacher will wait. Take your calculator now, okay, plus all the numbers. What do you get? Do you get 1? You should get 1. Okay, you must get 1. See, I've been telling you from the beginning that probability distribution, the entire calculation will always equal to 1. So if you have calculated all this correctly, you can always check in exam also. Plus everything. See, if you get 1, then your answers are all correct. Okay, so A, B done. Now it's time for us to plot the graph. Okay, you guys already learned to plot the graph. So teacher is going to show again here how to plot the graph. Okay, this time I'm not going to do mistake because previously I just actually accidentally switched the place. So let's do very carefully this time. Okay, we're going to draw the x-axis and the y-axis. So I need to increase the size. Okay, let's see. Okay. Hey, I'm supposed to insert. Sorry, hold on 1 minute. We insert my line. I want a bigger size. Okay, done. Okay, so can you guys see? Yeah, okay, now better. Okay, alright. Okay, so here, remember below will always be the R, above will always be the probability of x equals to R. Okay, so we write it slightly up, higher. Okay, here probability x equals to R. Alright, so always start with a 0 here and a 0 here. Okay, I've also explained why. Okay, you must start with a 0 here because R, do you realize your R, this is your R, starting from 0, 1, 2 and 3. Okay, so you always must have the R starting from 0. 0, 1, 2 and 3. Okay, what are my probabilities? So I'm going to use, since my probability, I'm going to use the scale 0.05. Okay, usually don't worry, you will be given graph paper, okay, in exam. So you don't have to worry, you will be given graph paper 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, 0.35. Okay, how much do I have? Until 0.5, right? Okay, I think I need to make it slightly longer up here. So I'm just going to increase all the way. Okay, I think you guys are still can see. Okay, 0.4, 0.45, okay, 0.5. I just want to make sure that okay, you can see the entire graph. We make it smaller. Okay, this is better. All right. Now let's fill in. Okay, the first one. Okay, make sure I do correctly. 0, 0.008. Okay, 0.008. So somewhere here is very low. Okay, and graph paper you can calculate accurately. Okay, for probability when x is 1, 0.096. Okay, so it's roughly going to touch the number 1, but not yet touch, roughly only. Okay, then probability on x is 2 is 0.384. Okay, 0.384. Somewhere almost towards 4, but not yet. Okay, and the last one when x is 3, 0.512. So slightly higher than 0.5. Okay, somewhere here. So now we draw a straight line. Teacher draw a straight line. Okay. So this was straight line like this. Okay, I think you guys can see now. Okay. Straight line down. Okay, straight line. Straight line. Alright. So we have already drawn our probability distribution graph. Okay, this is quite easy actually. Alright, this is quite easy. Alright. So usually there will be another question attached to this. Okay. Now teacher is going to continue straight. Okay, we are going to use the same question. Okay, usually you might be asked to find the mean, find the variance. Okay, find the mean, variance, and standard deviation. Okay. Now teacher want you guys to take a minute, pause. Okay, pause, take a minute. uh, Tell teacher why in the comment. Tell teacher why we need to find mean. What is the purpose for a set of data? Why we need to find variance? Why we need to find standard deviation? Why? 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 Okay. If you can answer correctly, I will feature your name. I'll feature your name and comment in my next video. In my next video, okay, I'll feature your name and your comment. I will paste it, and I'll definitely feature you. Okay. So let me know why mean, why variance, why standard, why we are using all this. What is the purpose? Because you need to understand, then only you know, oh, this is why we are using mean. You know that every day companies and all are using means, variance, standard deviation. But why? What is the reason? Okay. So for in this case, you just need to, after you understand, memorize the formula. Okay, memorize all this, because although it's given in exam, okay, this is my personal humble request, memorize. Okay, memorize formulas. It will be very helpful for you, because you will, during SPM sometimes you do tend to get panic or something. It helps. Okay, it helps. All right. So now, so we are, these are the formulas. NPN is number of trials. Okay, that's now you know already. P is success. So variance is NPQ. So that means N times P times Q. Standard deviation, you just square root your variance. Okay, so let's see now. The question say find the mean, variance, and standard deviation for this question. That's now. Okay, let's say there's a question D. Question D, find the mean, variance, and standard deviation. So first step, okay, let's say it's question D. Okay, we need to find the mean, isn't it? Okay, so you want to find the mean. What is the formula? NP. Correct? So what is our N just now? How many shots he did? 3 shots. Okay, so N is 3. What is the probability of him getting the strike? 0.8. So 3 times 0.8 is 2.4. So usually write 2.4 shots, the mean. Now if you understand why we are finding mean, you will understand why teacher write 2.4 shots. Okay. Let's say finding variance. Variance also easy. And PQ. Isn't it? Also variance actually you use like this, the symbol. Variance. Mean you use like this. Oops, sorry. Mean you use like this. Okay. So variance, N is 3, P is 0.8, Q is 0.2. Calculate, you get 0.48 shots. Okay, and the last one, standard deviation. Super easy if you already find your variance. Standard deviation is just like that, thing only. It's the square root of NPQ. Since this now we already find the NPQ, just take square root of 0.48. So you'll get 0.6928 shots. Okay. So, okay, I'm going to stop this part until here, because there's one more small part that we need to go through. Okay, for 5.2. Which is like finding probability, like at least you get 3 times the shot or less than 3 times the shot. So these kind of questions are also very popular. Okay, so we will move on. So Any question you guys want to ask, okay, comment down in section below. I'll definitely get back to you. Okay, now let's look at this type of question, which is also popular. Okay, okay, teacher read the question for you guys first. I don't know why I'm doing it. I just want you guys to see that the here part is actually 40%. Okay, 40%. They will ruin the entire 40%. Okay, 40% of the students. Okay, 40% of the students from a school lah. Okay, they are wearing glasses from a random sample of 10 students. So they're just taking a random sample, 10 students. Calculate the probability that exactly 2 students wear glasses. Okay, first here, let's write our binomial first. Okay, so x is the number of students wearing glasses. So make sure you know what is your x. Number of students wearing glasses. Okay, how do we write our binomial here? That means the one teacher have to write the x, okay? B. So what is my n and p? What is my n? My n is, the sample is 10 students. So my n is, this is n and p, yeah? So that means my n is 10. What is my p? Probability of students successfully wearing glass. 40%. See, they give you in percentage. That means here is 0.4. Okay, 0.4. So this is your x. This is what the first information you write down. Okay, now we can do question A. Okay, let's do question A. Find the probability that exactly 2 students wear glasses. So, what is our x? The probability that exactly, so put equal sign, equal to 2. So this one, straight away key put into the formula. So total n is 10, 10 C2, success is 0.4 power of 2, 0.6 power of 8. Okay, okay, so now let's calculate. Key in carefully, times everything, and C2 times 0.4 power of 2 times 0.6 power of 8. So we get in decimal 0.1209. We stop until here. So easy, the first one. Okay, the first one is doable. B. Okay, find the probability that less than. How do you write less than symbol? Like this, isn't it? Less than. So find the probability less than 2 students wearing glasses. Less than 2, so less than 2 means how many students are wearing glasses? That means maybe 0 students are wearing glasses. Okay, right here, 0 students. Okay, or maybe 1 student. 1 student is wearing glasses. So now, can I say 2 students are wearing glasses? Can or not? Cannot, because there is no equal sign, isn't it? So 2 students cannot. That means the probability is for 0 and 1 only. So in this case, what you do, you take the probability for 0 students and you plus with the probability for 1 students, because less than 2 means 0 and 1 only. Okay. So now let's calculate. So the first one for 0 is not, let me write nicely. Okay, 10 C0. Here is 0.4 power of 0, 0.6 power of 10 plus 10 C1, 0.4 power of 1 and 0.6 power of 9. Okay, so let's plus. First, the one we get is 0.4 times 0.6 power of 10. We get 0.00605. Okay, be careful because there's 10 times 10 to the power of -3. Okay, so just be careful. Okay, then plus the next one, just change the numbers. 1. Here is 1. Okay. 0.04031. So you plus this, the final answer we get 0.0464. Okay. So we continue with part C. Okay. So part C, if you see the question, okay, they say that find the probability that at least. So now our keyword here is at least. Okay, at least two students wear glasses. Okay, so how to write at least? Okay, at least means bigger than and equal to, greater than and equal to. So if my probability x is bigger than and equals to 2, that means two of the, this is 10 students, right? Okay, that means two of the students are wearing glasses or not? Yes, isn't it? That means x equals to 2. Three students wearing glasses? Yes, three students. Four students wearing glasses. So you plus. Five students wearing glasses. Okay. Six students wearing glasses. Okay. Then seven students wearing glasses. Eight students wearing glasses. Uh, down a little bit, 9 students wearing glasses and 10 students wearing glasses. So we have to find a probability for all of these. But there is a shortcut. You see, this is like the long method. You have to calculate one by one, one by one, one by one, and then you have to plus everything. Okay, so this is going to be too long. So what we do, we try to make it shorter. Okay, shorter method is, okay, instead of using greater than, okay, what we do now is we use the shorter method. Okay, what we do for the shorter method is, okay, here at least two students must wear glasses, isn't it? So at least two students. So students who don't wear glasses will be how many students? Zero students, okay, or maybe one student. So these are the only two options we have. Zero students wear glasses or maybe one student wear glasses. Okay, so what we do is we take 1 minus the probability of x equals to 0, that means 0 students, and the probability of x equals to 1 student. So that will be a shorter method for us to calculate. Okay, for us to calculate. So instead of doing this long way here, one by one, we take 1 minus. Why 1? Because entire probability distribution will always be 1. So from here we calculate 1 minus, okay, probability x 0. So you don't have to calculate back. Remember here just now we already find 0 and 1. So we can straight away put this value 0.0464. So 1 minus 0.0464. So this is the answer from B. Yeah? This one is the answer from B. So when we minus, we get 0.9536. So this is the probability that at least two students will wear glasses. Because if you also use the long method, okay, you still should get the same answer, 0.9536. But let's not waste time for the longer method and go for the shorter method. All right. So I have written here the question for you guys. Company has 5 telephone lines. The probability that a line is engaged at any moment is 0.4. Find the probability that at any moment all the lines are engaged. At least 3 lines are engaged. At least 1 line is engaged. Okay, so teacher hope that you guys try this question. Comment below your answers. Okay, I will definitely get back. I'll tell whether your answer is correct, okay, or it's incorrect. You need to do some correction. So thank you so much for watching. Until I see you in part 3. Okay, keep practicing, guys. Okay, take care.